Got a brand new battery in this. Okay, here we go. So it's kind of a review lesson today, and 10, 11, 22. So I see a pattern, and sequences can be numbers, and they also can be figures if the figures have a pattern. So I can see it's 1, 2, 3, 4, 5, 6. So the next one's got to be what? 7 high, right? 7 high. 1, 2, 3, 4, 5, 6, 7 high, 7 out, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oops. 1, 2, 3, 4, 5, 6, 7. Oops, too high. And then I'm just going to make the rest, right? And then I'm going to make the last one. It's got to be 8, I think. And then, just draw on my figure, and this is pretty easy. I do not have very nice looking figures, but And then my sequence would be a 1, a 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 21, ... That's my sequence. So I'm add 2, add 3, add 4, add 5, add 6. So there's my pattern, right? Let's see if I can find my red pen. I can never find a red pen because everybody likes my red pen, so they borrow them and never give them back. I don't know if they call that borrowing or not. If you borrow it and never give it back.
That's something that Jonathan Young does.
Yeah. So the pattern's like plus 2, plus 3, plus 4, plus 5, plus 6, right? And then we can keep making the rest and the rest, okay? Of course, this is kind of the same way. So I'd have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's see, my sequence is 3, 1, 2, 3, 4, 5, 6. I think it's the same thing. 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. No, 12, 15. So this one's we're just adding 3, adding 3. This one's just plus 3, plus 3, plus 3. Okay. And this would be the same thing. Let's see, we have 3 circles, 5 circles, so 7 circles. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So on my pattern, or my sequence would be 1, 3, 5, 7, 9. Am I going too fast?
Yeah.
Okay, I'll slow down, wait for you, okay?
Wait, what are we supposed to be doing?
So draw the next ones, and then I'm just describing the sequence. There it is.
Wait, you want us to draw the next 2?
Yeah, I think you want to draw the next 2. I think it says draw the next 2 figures and describe the pattern, okay? So draw the next 2 and describe the pattern. So I'm kind of describing the pattern. Here's like plus 2, plus 3, plus 4, plus 5, plus 6. This one's plus 3, plus 3, plus 3, right? This one's just the odd numbers, odd integers, positive, odd positive integers. 1, 2, 3, 4, 5, 6, 8, 9, 10, 7, 1, 2, 5, 1, 2, 3, 1, 2, 3, and then 1, and then 1. Okay, there's that pattern. And I would have, let's see, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I get 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's the squares. Ah, I bet you can rearrange these into squares. What do you think, Mr. Lane? I bet we could rearrange these and we'd make squares, wouldn't we? We'd have to, because there's my numbers. So it's just square numbers. Decreasing, right? 5 squared, 4 squared, 3 squared, 2 squared, 1 squared, right? And technically 0 squared is there. How am I doing? Am I doing okay? I'll wait for you. I'll wait for you. Guys, give me thumbs up when you're ready. Jonathan's good. Hannah's good. Vanessa's good. Carter's good. Okay. Sit Lolly's good. Jenny, are you good? Yep. Josue, you good? Okay. Noah's good. Okay, turn the page. All right, so what I'd like us to do is find the next terms, okay? And then, so what's going on? It looks to me like, what are we doing? What are we doing?
It goes times 4.
Times by 4. So R is 4, right? So the next two terms, I just need a calculator, which I have right here. R is 4. 192 times 4. 192 times 4. I've got 768 times by 4. I get 3,072. Okay, good. How about number 4? What's going on? Okay, I agree. Negative 2. R equals negative 2. So I'd have negative 72 times a negative 2 is 144. And then times by negative 2 is negative 288. Good job, Hannah. Number 5, we're just adding another 1, right? So it'd be 1.11111 and 1.11111. That's it. So this one's neither geometric nor arithmetic. So there's no rule. You can't really say add something or to multiply something. It's just the way it is, okay? Let's see. What are we going up by or down by? 12, I think, maybe. Down by 12, down by 12, down by 12. You guys agree with that? So negative 32 minus 12, negative 32 minus 12, negative 44 minus 12, negative 56, okay? And I'll let you catch up, okay? Okay, I'll let you catch up. Everybody good? I'll wait a second. Now, on number 1 on problem set 5, we got to come up with a rule, okay? And it wants recursive. We want recursive, okay? So they already kind of did 1. A1 is 4. An equals a to the n minus 1 times 2, okay? That is my formula for number 1. That is my recursive formula. Oh, they like, I keep doing A's instead of G's. They like G's. That's my formula for number 1. They like G. I'll change it to G's. G's of 1 and G's of n and G to the n minus 1. 2, what's going on in 2? Plus 14? Do you see plus 14? So I know it's arithmetic. So I'm going to go A1. So my first term is 16. I got to tell it, I have to say start here. A1 is 16. And then I'm going to go my A to the n minus A to the n equals, my bad, equals A to the n minus 1 plus 14. Okay. So I've got to tell the first term, what is the first term? Start here and then add 14 to the previous term.
Wait, what?
So start at 16 and then take the previous term and add 14. A to the n equals A to the n minus 1 plus 14, okay? Yeah. Can she wait a little bit? I'm giving good notes.
Yeah, we should.
All right. So let's look at the next stuff, okay? All right, so if I look at the next question, I'm missing a number. What goes right here? How come? I agree. How come? Everybody agree with Josue, including me? So then 162, nice job, Josue, times negative, and I get negative 486. What's going on here? I think I'm adding 2.1. Can you see that where I'm adding 2.1? Do you see I'm adding 2.1? So what's 11.5 plus 2.1? 13.6 and 17.9. 17.9. Hey, Mr. Lane, yeah. Thank you. Yeah. Is this helpful? Okay. Turn the page. Okay. All right, we're cruising on this. All right. So, what's going on?
And then this one. Goes 590.
I think we're adding 90. Are we adding 90? Plus
And then the next one
90,
is
590,
not, it's 6,
and then 590 plus 90 is, 680.
Oh, my bad.
That's right. That's what calculus is made for, right?
It's a minute.
So D equals 90, okay. What's going on here? R is 3, so it's geometric. 63 times 3, 189. 567 times 3, boom, 1,701, okay? Okay, explicit formula. So they used this formula because it's the explicit formula for arithmetic. And it looks like D, I'm adding 3 each time, so they put the 3 there and they evaluate. So number 2 looks to me like this one is subtract 5, subtract 5, subtract 5. So I'll start with A of n equals A1 plus n minus 1 times D. Okay, and I'll let you catch up. There's my arithmetic formula, okay? There's my arithmetic explicit formula. So I've got a arithmetic explicit formula. Okay, then I'm going to go, okay, A of n equals A1, which is negative 10, plus n minus 1, and D, which is the difference, is negative 5. Okay, there's my formula. Okay? There's my formula. And now I want to find the 30th term. All right, so I'm going to go a of 30 because I'm looking for the 30th term. So plug 30 in for n. All right, negative 10 plus 30 minus 1 times negative 5. Okay, so plug my first term in. N is 30. And then I'm just going to use my calculator. Yeah. Negative 10 plus parentheses 30, subtract 1 times negative 5, and I get an answer of a 30 is negative 155. Awesome. Okay, 3, what's going on? What's going on in number 3? What's happening in number 3? Yes, D is 1.1. Awesome. Thanks, Hannah. A of n equals A1 plus n minus 1 times D. Let's start there. That's my formula. That's my explicit arithmetic formula. All right, A of n equals 3.3 plus n minus 1 times 1.1. Okay, so there's my formula. It's going to be... So now let's use our formula. So I'm going to plug in. 25 goes there and there to use my formula. So I'll go A of 25 equals 3.3 plus 25 minus 1 times 1.1. I'm just going to use my calculator. I'm going to go 3.3 plus parentheses 25 subtract 1 times 1.1, 29.7. 29.7. Okay. How am I doing? We're just about done with this thing. Okay, so number 4. What's going on? Number 4, what's going on? What?
Next one will be 76.
Right, so we're subtracting 8, right? So I'm going to start with my formula. A(n) equals A1 plus n minus 1 times D. I'm going to start with that formula. A(n) equals 100 plus n minus 1 times a negative 8, because that's my difference, right? So that's my formula. And then plug 50 into my n. So if I rewrite as A of 50, what is the 50th term? 100 plus 50 minus 1 times negative 8. I don't know. Let's see what we get. 100 plus parentheses 50, subtract 1 times negative 8. Negative 292. Okay, number 5, what's going on? Number 5, what's going on? Plus 2.25. Awesome. Totally agree. So I'm going to go, all right, A of n, here's my formula, equals A1, which is a 12.25 plus n minus 1 times my 2.25, right? There's my formula. I'm just using this formula. I just didn't write it down because I already had it. And then I need the 42, so I'm going to plug 42 in, right, for n. So we'll have A of 42 equals 12.25 plus 42 minus 1 times 2.25. Let's see what we get, okay? 12.25 plus 42 minus 1 times my 2.25, enter. Okay, now I'll let you guys finish this. Same thing on the back, I'll let you guys finish this. And then this including what's in the book today. So finish this. So today, finish this. We've got lots of time. We've got a half hour. Finish this. And I want you to do page 131, 132, and any Mathia you have to do. We got lots of work to do with the exception of maybe a couple of you, but most everybody has something to do. I'm sure of that, right?